Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about a Leetcode question number 2370, longest ideal subsequence. So you are given a string S consisting of lowercase letters and an integer k. We call a string T ideal if the following conditions are satisfied. What are those conditions? First of all, T is a subsequence of the string S. The absolute difference in the alphabet order of every two adjacent letters in T is less than or equal to K. Okay. Now I want to return the length of the longest ideal string. Okay. So they are asking us the length, not the longest ideal string. They are asking the only the length. Okay. Fine. Now what is meant by subsequence? So subsequence is a substring of a main string where we will be deleting some characters. Okay, or maybe we don't want to delete anything also. What it means? So see here, if I have ABCD, I can say AB is a subsequence, ABC is a subsequence, BC is a subsequence, BD is a subsequence, AC is a subsequence, or ABCD is a subsequence. But I cannot tell you BD is a DB is a subsequence because order is changed. Okay, so this is what the subsequence means. Now they also given a note. See here, the alphabet order is not cyclic. Not cyclic means what? See here, after Z in cyclic it will be A. After Z in cyclic it will be A. If it is not cyclic, then after Z it is not A. So the difference between A and Z is going to be 25. That's what they have given here. Okay, fine. Now let us see about this example ACFGBD. So here k value is given as 2. Now if I ask you to find out the ideal subsequence, then I will be telling you ACBD is going to be my ideal subsequence. Why? Because see here, what is the difference between A and C? It is 2. 2 is equal to 2, the k value, right? Okay, C and B, it is 1. 1 is less than the k value, fine. Now B and D, again it is 2. 2 is equal to k value, okay, fine. So that's the reason why it is an ideal string and we cannot construct any other string which has a maximum length or which has a greater length than this string. Okay, you may think of ACFBD, but C and F, whether their difference is less than or equal to 2? No, that's the reason why we are not taking those strings. So our subsequence is consisting of 4 length, so we are returning 4. Can you understand this? Fine. Now let us see about the logical part. So at first our mind will be going to the greedy algorithm, right? Greedy algorithm. Whenever there is a minimum or maximum, longest, smallest, absolutely our mind will be going for a greedy algorithm. But here the greedy algorithm will be failing. Why? Because see here, I am starting from this A. Whether I can take this C or not. Sometimes if I take this C, I may have some value which is less than the front value. Here it is A, but in some cases less than this value. So we will be going with these parts, leaving this C behind it. In some cases, the C is taken mandatorily. Can you understand this? So this problem is not following the uniformity concept. Hence, we cannot use the greedy algorithm. So the greedy algorithm fails. Okay, then you may ask, hey, what is the brute force approach, right? So the brute force approach or the easiest approach you have, and also it is an inefficient approach also. Just generate all possible subsequence, and then whichever satisfy my condition, just take them. That's it. Easy, right? So this is going to be a brute force approach, but it is a very time inefficient. So we want to go with some particular approach in which we will be going with the all combination of a subsequence, and also we are building with the logic. So now we are getting into a recursion and backtracking, the combination approach. Okay, so if you don't know about the recursion and backtracking, I will be giving you the link in the description. Just go and watch it so that you can understand what is in my recursion stack, what is in my recursion tree, and how the recursion works in a DFS manner. Okay, fine. Let's get started. Whenever it is going for a combinations or recursions, first of all we want to define the function, right? So what is going to be a function and what is going to be the functions varying parameter. So I want to keep track on where I am standing currently, right? So for that I will be taking a index, and for example, I am standing at this G, okay? Whether I want to take this G or not, I want to decide, right? So to decide that, I want to know about the previous value. So I want to take the previous value. So here we have two choices. Either you can take the previous value or take the previous index. So it is a choice up to you, but my request is check the constraint. So see here, the constraint is S contains of lowercase English letters, okay? But S length will be up to what? 10 power 5, which means if I go with the index, then it reaches up to 10 power 5 minus 2, okay? If I go with the values, then it will be reaches from 0 to 122, because 122 is a small z value, okay? And capital A value is of 97, but we don't want to take only 26 characters for the simplicity. Always remember, you don't want to go with the optimized version at first. Always remember that. Let us make the code work first, then let us make the code optimization next, okay? That's what the mentality you should have whenever you are going for a problem solving. Fine, okay? That's the reason why I am not taking just of 26, okay? To make it simple, I have taken from 0 to 122. 122 is going to be the value of small z, the ASCII value. Fine. Now, starting from where? I want to start from 0th index, and what should be my previous? Previous, just I keep it as -1. -1 denotes, hey, you don't have any of the elements previously, okay? So let me take the example again. Fine. See here, I have two choices. What are them? Either I can take this A, or I don't want to take this A, okay? If I take it, I want to check the condition. What is the condition? My previous value and my current value difference should be less than or equal to k, or else it may be the first value I am taking. Yes, you may take any values at first, right? So this -1 represent, hey, you don't have any previous value, so I can take this value, right? So whenever I am taking some value, I want to add 1 to it, okay? And I want to go to the next index, comma, I want to update my previous as the current index, which means 0, because this 0th index is taken, right? So this is for the index method, this previous index method. If you are going for a previous value method, what is the previous value you have taken? It is A. Then you want to update this as 97. Can you understand up to this, right? Okay. Now for not take, we don't bother of any conditions, right? Just go to the next thing and keep the previous as it is, because you don't even took anything. Then why should you worry about, right? Okay. Now again here I have two choices, take and not take. If I take, I want to check. Okay, what is the first index? It is C. Okay, what is the ASCII value of C? It is going to be 99, I think so. Okay, now 99 minus 97, which is equal to 2. What is the k value? K value is also is 2 or 3, right? So 2 is less than 3, so I can take it. Okay, take it. So 1 plus f of, go to the second value, and what element I have took? C. So what is this ASCII value? It is 99. Okay. If I don't take it, that's your choice. Go to the next value and just keep the previous as it is. Now here also you have take and not take. Whether I can take? Yes, you can take, because it is -1. If I take it, it will be f of 2 comma, what is the first value? It is C, right? C means it is 99. And if I don't take it, it will be 2 comma -1. Okay, fine. Now here again I can take and not take. For take, I want to check the condition. So what is the condition? This G. What is the ASCII value of G? So A, B, C, D, E, F, G. So here 99, then it is going to be 100. Here it is going to be 101, and here it is going to be 102, and here it is going to be 103. So 103. So 103 minus 99, which is equal to 4. 4 is strictly greater than 3. 4 is strictly greater than 3. Then I cannot take it. Right? So whenever I cannot take it, I just return the value as 0. I just return the value as 0. Okay. Now for not take, there is nothing. Okay. So just take 3 comma 99, 3 comma 99. Now again listen this carefully. So here whether I can take it, no, because I am standing at 2. I am standing at 2, which means this G, and what is my previous character that I took? It is 97. It is 97, which means A. So 103 minus 97 is greater than 3. So I cannot take it. So it will be returning 0 for take. And for not take, you can continue. If I continue, it will be 3 comma 97. And here also similarly for take, you cannot take it. Okay, understand this. For not take, you can go to the third index, take this as 99. And here you can take actually. Okay, if you take it, it will be 3 comma, what is the G's value? It is 103. Okay, if you not take, that's your wish. F of 3 comma minus 1. Okay, come here, let me finish this quick. So take and not take. If I take it, I want to check what is the third index value. It is E. What is the E's value? It is 101. So 101 minus 99, which is equal to, what is the value? It is 2, right? So 2 is less than 3. 2 is less than 3. So I can take it. So if I take it, it will be f of 1 plus f of 4 comma, which element I have took? E. So E ASCII value. Okay, if I don't take it, that's your wish. Okay, now see here, I want you to understand this and complete this tree. Okay, just understand this step so that you can complete this tree successfully if you know about the recursion tree. Fine. So understand this. What is this value? It is f of 4 comma 101, which means I am standing at 4th index and my previous value is 101. Okay, fine. Whether I have 4th index? No. Whenever my index reaches my end, I want to return 0. Okay, here also my index reaches the end, so instead of this, return 0. Okay, now here this will be substituted as 0. 1 plus 0 will be 1. Now in my left recursion, it is returning 1. In my right recursion, it is returning 0. Which should I take? I should be taking the maximum value because they are asking the longest subsequence. So take the maximum value. So 1 is the maximum value. So here it is returning 1. So 1 or 0, 1. So replace this as 1. So 1 plus 1, this is going to be 2. So just complete all the recursion calls. Okay, and then just take the maximum value among the return values, and whatever value comes here is going to be your resultant. Can you understand this? I want you to complete this recursion tree. That's your job. Okay, fine. Now what is going to be the time complexity? So time complexity will be O of, see here, 2 power n going to be the length of the string, cross what is going to be the total value? It is 122. Okay, so it is approximately not 122, it is approximately equal to 26. Okay, because there are 26 characters, and it can be approximately equal to O of 2 power n. Okay, and what is space complexity? It is O of again n into 26, so constant will be eliminated, so O of n. So this is going to be your time and space complexity analysis for the brute force approach or a recursion approach. Okay, now let us see the code, then we can go and optimize the approach. Fine. So here I have written the Java code. If you want C++ or Python code, just go and search in the description. Fine. Now see here, I am just calling the recursion function of index as 0 and previous value as -1. Now what is going to be base condition? If I reach the end, if I reach the size, then I want to return 0. Okay, and take is equal to 0 initially, and current is going to be the current index value, that character. Okay, now I am just checking whether the previous is equal to -1, or else my difference between the previous value and the current value is less than or equal to k. Any one of the condition is true, then I want to go for a take condition and store in the take variable. Okay, and after finishing that, I will be going for a not take. Okay, and it doesn't have any conditions. At last, I will be returning the maximum among them. That's it. So this is going to be your entire recursion code. If you submit it, it is not going to be submitted successfully. So So let me optimize it. So what is going to be the next optimization technique? So the next optimization technique is going to be memoization. Memoization. Okay, what is in my memoization? I'll be storing each and everything in my memory, and whenever I need it again, I just don't want to go again, just I'll be taking from my memory. So here we can do this using array or hash map. So in this video, I am going to cover this array approach because this array approach is quite difficult to build it. Meanwhile, the hash map approach is easier once you studied about the array approach. Okay, fine. So see here. Let me take you some example. See here. Just see the yellow color mark. So here it is what? F of 2 comma 99. Similarly, here it is what? F of 2 comma 99. So here it is returning 2 as my value. So I'll be storing this 2 in my brain. Okay. As you know, the recursion is a DFS approach. So first this will be computed. Next only this step is coming, right? So instead of going for all these recursion calls, I will be taking out from my brain, and here itself I will be returning as 2. So there is no inefficient steps. This will be reducing me the time consuming. Can you understand this? Can you understand this? So this is the main core logic of the memoization approach. So here you can do with the hash map approach, or you can do with the array approach. But hash map approach is recommended for easy thing, like you don't have time. You don't have time in your interviews. You want to do it in 10 minutes or 5 minutes, you can go with the hash map approach. But if you have plenty of time and you want to, you are trying to optimize it up to the space optimization, then just go with the array approach. Okay, fine. Now, so what are the steps for the memoization technique? So the first step is designing the array. Okay, so see here, how we are going to design the array is, first of all, we want to find out what's the dimension of the array, right? So here, how many varying parameters are there? One is this index, another one is the previous value. So there are 2 varying parameters. So it is going to be 2D array. Now tell me what is the size of the array? Okay, so see here, my index is starting from 0 and ending at where? Ending at s dot length minus 1. If it is s dot length, then it will be returning 0. That's the reason why it is ending at s dot length minus 1, which means I want n rows. N rows. Okay, which means 0, 1, 2 going up to n minus 1 as the index. Okay, n rows cross. What is my starting value of the previous? It is minus 1. And what is the ending value of the previous? It is going up to where? It is going a possibility of 122, which means from minus 1 to 122. But here in your array, whether you can put any indices minus 1, no, right? Always the index will be starting from 0, right? So instead of minus 1, I will be adding 1 to this minus 1 such that it will be replacing as 0. So for this 1, it represents the 0. For 2, it represents 1. For 3, it represents 2. For 4, it represents 3, like that. So it will be previous plus 1. So previous is converted into what? Previous plus 1. Can you understand this? Yes. Okay. So it will be going up to what? It will be going up to 123 because what is the z value? It is 122. So previous is becoming a previous plus 1. That's the reason why it is 123. So what is going to dimension? It is n cross 124. So this is going to be a dimension of the 2D array. Okay. Now what is going to be the initial value of these all the table value? So what is going to be the value? So see here, what value is not repeating here? What value is not returning here? So it is negative value is not returning here. Minus 1, minus 2, minus 3 is not returning here. Infinity is not returning here. Minus infinity is not returning here. Null or none is not returning here. So you can take any one of them and replace all the table values as that value. You can take minus 1 and replace everything as minus 1, or you may take null and replace everything as null, or you may take minus 2 or infinity or minus infinity. That's your wish. Okay. So here let me do it minus 1. Okay. Now what is the next step? The next step is you want to add one more base condition. What is the base condition? If take for example, this is a DP array, okay? If DP of I and, so here previous is -1 here, right? -1, which is equal to 0, which means previous plus 1. If previous is -1, then I will be doing +1 to make this as 0. Can you understand this? Can you understand this? Okay, fine. So if dp of I and previous plus 1 is not equal to -1, then just return dp of I and previous plus 1. That's it. Okay, and then before returning this value, before returning it, okay, we want to, instead of this line, we want to add another line. So like just store it, just update it, then return it. So dp of I and previous plus 1 is equal to maximum of take and not take. That's it. Okay, then just return it. Then just return dp of I and previous plus 1. That's it. Can you understand this? Okay. Now why I am doing this line? This line is I am checking whether it is already computed or not. If it is already computed, then don't want to go for any recursion calls. Okay, and then for this line, I'm just updating it, okay, and then I'm just returning it. Can you understand this? So this is what I have done to make the recursion code into a memoization code. Okay, fine. So what is the time complexity of this? So the time complexity will be hugely reduced. What is going to be the time complexity? O of n, and space complexity also O of n, without using the constant. Okay, so the space complexity is because of two things. One is recursion stack, another one is because of what? Another one is because of the array or matrix we have taken here, right? So these two factors are affecting my space complexity, but the time complexity is hugely reduced, right? Because there is no repetition. That's the reason why it is O of n. Fine. So this is going to be your entire code for the memoization. Let us also go for the coding part so that you can understand the memoization technique clearly. So see here, I have declared the DP array. Now I filled everything as -1, or you may take this null or none or infinity or minus infinity. That's your wish. Okay, then where I have changed rest of them. So I have changed here I have included one more base condition. Then here I have updated it. That's it. So these are the only thing, or these are the only changes I have done here. Other than that, there is nothing changes, right? Fine. So let me take this. Always remember, memoization technique is quite easy. Okay, that's the reason why I don't want to go beyond this. Okay, this explanation is enough for you to do the memoization technique. Now what is the third technique is tabulation technique. So see here, I just teach you how we are going to convert the memoization code into a tabulation code. It is also a bit easy, but it is quite harder than the memoization approach. Okay, so see here, the core thing we are doing in the tabulation is we want to eliminate the recursion stack. If I want to eliminate the recursion stack, I don't want to use the recursion, I want to use the looping. That's the reason why I am going for the tabulation. So what is the first thing you want to do in a tabulation? So the first thing you want to do in a tabulation is just go and check whether we want to modify the array or not. See here, for example, if it is AC GE, okay, so what, and the k value is of 3. Okay, now what is the length of the string? It is 4. Okay, now how my matrix looks like in my memoization? So in my memoization, the matrix looks like 0, 1, 2 and 3. Okay, and here it will be starting from 0, 1, 2 going up to what, 123, right? Okay, now this is what the actual matrix looks like in the memoization approach. Now in your tabulation, you want to focus on the base condition. So what is the base condition? Base condition is if the index is equal to the s dot length, then I want to return 0. Okay, which means I also want I which is equal to the length 4. That's the reason I added this particular index. Okay, now what is the initial value? So the initial value is filled with -1 already, right? But now what should I written at the particular index number 4 when it is equal to the length s dot length? It is equal to 0. I want to return 0, right? So just fill this last row as 0 because of the base condition. Can you understand this? Can you understand this? Yes. Okay, remaining part you may take this as -1 or 0, that's your wish, because remaining part will be updated. Okay, so after finishing the code you can understand why I am telling you that remaining part can be anything. Okay, just be patient. Okay, what is the next thing? Next thing is eliminate this line. Okay, now rest of them is a body. Rest of them is the body of the recursion. Whenever reach the body of the recursion, put a for loop. For what is the first parameter? Varying parameter is I. Okay, I is starting from where? Is starting from 0 and ending at where? Ending at s dot length of -1, right? So here you want to do in a reverse fashion, which means start from n-1. Start from n-1, go up to 0, right? 0. Okay, again put for, then it is previous, right? Previous. It is also starting from where? It is starting from -1 and ending where? Ending at 123, right? 123. So here you can do like in two ways. You can either reverse it or you don't want to reverse it, because here the values are fixed, right? Here the values are fixed. You know that it is from 0 and going up to 123. So here it is constant. So just write 0 and going up to what? 123. That's it. So here this constant, you can do it in any way. Okay, fine. Now what is the next step? Next step is write these lines here as it is. So take is equal to 0 and then current is equal to s of I. Okay, now if my previous is equal to -1, instead of using equal to -1, just use equal to 0, because here we are using what? 0. Okay, so here you can use previous is equal to 0. Okay, or my absolute difference between current minus previous is less than or equal to k. Then what should I do? Just take it. Take is equal to 1 plus, here it is what? A recursion call. Whenever there is a recursion call, use the dp, the matrix name. Okay, dp of what is the varying parameter? It is I plus 1 and another varying parameter is current. So current, that's it. Okay, then here comes not take is equal to, what is the value? It is again the recursion call. So dp of I plus 1 and previous and at last dp of I and previous is equal to maximum among take and not take. That's it. So at last, after finishing the entire for loop, just to return what? What is the value we are returning here? We are returning recursion of 0, -1. So here also you should return dp of 0, 0. Okay, because there is nothing like -1. Okay, that's the reason why I am returning 0 for the previous also. That's it. So this is your entire tabulation code. Okay, now tell me what is going to be the time complexity. So time complexity will be O of n and space complexity is also O of n, but the space complexity is reduced via, it is only because of the matrix, not because of the recursion stat. That's it. Okay, so let me show you the code, just a minute. So just a minute. So see here, this is going to be your code. Yes, so as I already told you, our dimension will be changed to n plus 1, that n plus 1, from n to n plus 1. I already told you, right? Now what is the next thing? The next thing is I value will be starting from n minus 1 and going up to 0, and meanwhile my previous value will be starting from 0 and going up to where? Going up to 123. That's what I have written here. Okay. Now take is equal to 0. These and all the same thing as I mentioned in the drawing explanation. Now here instead of the recursion call, I want to do a memoization array, the dp and I plus 1 and the current character. Now here not take also the same thing I have done there. Okay, and at last we want to update it, so I have updated here, and at last while returning, always return the value, like whatever value you are returning in the memoization, just take that in form of the dp array, okay. But you may ask, hey, here it is minus 1, here it is minus 1, why are you taking a 0, here? Hey, minus 1 is not at all in a index. That's the reason why we already altered the previous to previous plus 1. That's the reason why I am returning 0. Can I understand this? Okay. So the next optimization technique is space optimization. So this is the last. Okay. So please be patient. Okay. So see here, what is the next optimized approach? It is optimizing the space. So it is called as a space optimization. So what is going to be the space optimization is, we want to check whether we are using additional space or not. Okay. So see here, how we are going to check is, go to the inner for loop, and go for the updation part or calculation part. So see here, dp of I plus 1. Okay, here also dp of I plus 1, here it is dp of I, which means this indicate what? This indicate, hey, you are only taking dp of I and dp of I plus 1, which means hey, you are only taking 2 rows, then why you want to take all n plus 1 dimension as a row? Can you understand this? This represent, you can take only 2 rows, of how many columns? Of 124 columns. That's it. For simplicity, you can also tell, like, take two variables, next and current. So next is going to be of size 124 and current is of size 124. That's it. So instead of this dp, just replace with this 2 lines. Okay. What is the next step? Is, wherever it is dp of I plus 1 replaces next, wherever it is dp of I replaces current, and at last we want to store the current in my next. What I am mean to tell is, see here, here instead of this dp of I plus 1 replaces what? Next. Here also instead of dp of I plus 1 replaces next. Okay, these 2 parts. Okay, now here you want to replace as current, and after finishing this entire for loop, this inner loop, I want to just update my next as my current. That's it. Okay, so clone off. That's it. Okay, so at last what should I return? So here I want to return, either you can return current of 0, or you may also return next of 0. That's your wish, that's entirely your wish, but you want to initialize both of them in this part. If you initialize the current in this particular point, then you cannot take the current and return here, it will be showing the error. Okay, so now tell me, what is going to be time complexity? It is going to be O of n, but space complexity is O of 124 cross 2, which is almost equal to O of 1. So we are optimized the space also. Can you understand up to this? So now what is your homework is, try to do this using only of 26 space, 26 cross 2, or you can also do this using 26 space also, because I think so here instead of taking the dp, instead of taking next and the current, we can only take one array also. That's also fine, because we are not using that one array again and again. So here you can take that same thing, here also you can take the same thing, here also you can take that same thing. Okay, just try it. Just try this of taking of computing the solution for space complexity as O of 26. That's your homework. Okay, now just see here, let me show you the code, just a minute. So see here, next and current. Okay, now everything are similar. The only difference is here, instead of dp of I plus 1 took us next, instead of dp of I plus 1 took us next, and dp of I took us current. Okay, and at last I want to update the current value in the next, and at last I am just returning either the next or current. So many of them will be still confused of this, right? I can understand that. See here, what I am supposed to do here is just follow the white color part. So initially I will be taking these two things. So this is going to be next, this is going to be current. So 3 is going to be current and 4 is going to be next. And I computed everything and stored in the 3 In next time, this 3 is acting as next and this 2 is acting as current. Now I am again computing everything and stored in this 2. Now this 2 in next iteration acting as next, and this 1 is acting as current. Okay, and computed this one value, this entire row value, and in next step this will be current and this will be next. Now again I am computing the entire this zeroth in this value, zeroth in this entire zeroth row. Okay, and at last from here I will be returning the value. That's it. Can I understand this? So this is what we are doing here. So we don't want the entire n spaces, n plus 1 spaces. We only want 2 spaces. That's the core logic behind it. Okay, hope you understood up to this, and if you really like this video and subscribe to my channel, and don't skip any videos in this DP series, because after watching this entire DP series you can able to solve the DP questions. And if you have any doubts or if you cannot understand any part, just comment below. I will be commenting the answers for it. Thank you.